Okay, so in this lesson, we're going to look at the different types of chemical reactions. And before we do so, let's do some more review from our previous units. In our chemical and physical change unit, unit 2, we learned that 4 things indicate a chemical change. And we did an activity where we saw all of these things happen. We saw that there was bubbles being produced. We saw that there was a color change in one of them. We saw the production of heat and light, and we also saw the formation of a solid. So we've already done that activity. It's linked up on to Canvas. So my suggestion, if you need to go back, rewatch that video and look at those changes if you need to. Okay, so a change in color. And now this is a big change in color. This is one color to a different color. So going from 2 clear substances to white. All right, we're going white to yellow. All right, a change in color. Gas production, which we see in the formation of bubbles. The formation of a solid, which we call a precipitate. And light or heat, And we also learned about 7 diatomic elements. And if you'll remember our 7 diatomic elements, to remember those, we use our anacronym, Hunkel-Briff. All right, and these are the 7 elements that are nonpolar. Remember, they're nonpolar. Di means 2 because they have 2 of the same atom. And we learned that when you have 2 of the same atom, it is a nonpolar bond. Now, these will always appear in nature by themselves when not in a compound as a form of 2 of the same atom put together. So oxygen is O2. Nitrogen is N2. Chlorine is CO2. Bromine is Br2. Iodine is I2. And fluorine is F2. So here's our 7 diatomic elements when in nature found by themselves appear in the form of 2 atoms nonpolar bonded together. So let's use this information and let's talk about our 4 main types of chemical reactions. Our first type of reaction is a synthesis reaction, and this is when we take 2 or more substances and we form a compound. So in a synthesis reaction, we have only one product, and this is important. So you can determine a synthesis reaction if there's only one product. Remember, the products are on the right side, and I only have one. Now, there are 2 units of product, but there's only one type of product, and it is PBr3. All right, so that would be PBr3. All right, I took 2 things, phosphorus and bromine, and I made one product. Same thing in this example. I took 2 things, sodium and chlorine, and I made one product, NaCl, our sodium chloride. A decomposition is the opposite of synthesis. So if synthesis has one product, the opposite of product would be reactant. And check this out. We have only one reactant in both of these examples. So only one reactant. So synthesis and decomp are opposites. All right, so a single compound is going to break up into 2 or more substances. All right, we have 2 more. We have a single replacement, and now this is where one element replaces another element in a compound. So we have on the reactant side a single element and a single compound. The product side also has one element and a single compound. So you can determine a single replacement if you have an element and a compound in both the reactant and the product side. Element compound as a reactant, element compound as a product. Element compound as a reactant, element compound as a product. Now, we have two types of single replacements. A metal can replace a metal, or a non-metal can replace a non-metal. A metal will never replace a non-metal, and a non-metal will never replace a metal. Okay, so it's just metal replaces metal, non-metal replaces non-metal. I know that potassium is a metal, so potassium can come in and kick aluminum out all by itself, and now potassium is part of the compound. So potassium metal replaced aluminum metal. Same thing here. Lithium can come in and replace the sodium. So sodium is now out by itself, and lithium is part of the compound. Lithium metal replaced sodium metal. Now, non-metal replaces a non-metal. Chlorine is the non-metal. Iodine is a non-metal. So chlorine can kick iodine out by itself, and chlorine becomes part of the compound. All right. Bromine can kick fluorine out, and bromine becomes part of the compound, and fluorine is by itself. Now, in these examples that I have provided, some of them don't actually work in real life, in nature, okay? So when you get to chemistry, for example, next year, you're going to learn about the activity series. And you're going to learn how to determine, will these reactions work, yes or no? So you'll get this activity series on your reference tables, and you'll learn that, for example, this reaction really is a no reaction. Now, I'm not really concerned in the purposes of this class that you know this reaction does not actually happen in real life. I just wanted to provide it for you so you could kind of see where we're headed when we go to chemistry next year, okay? And the next level that we're going to take these notes. Our final reaction is a double replacement. All right, and this is where ions in two compounds change partners. The cation, and I know it's the cation because it's positive, and now if you'll remember, T for in cat, positive symbol is the same, is going to combine with the anion from another compound, and if you'll remember, N for negative. So basically what we have is we have two compounds, both as products and as reactants, all right? Two compounds, both as products and reactants. I have a compound on the reactant side, two compounds, and I have two products or two compounds in the product side. I have two compounds as reactants and two compounds as products. And so you will always be provided the entire reaction in this course. And your goal is to determine, is it a synthesis, a decomposition, a single replacement, or a double replacement? Really, all you have to do is look at the reaction you've been provided. If there is one product, it is a synthesis. If there is one reactant, it is a decomposition. If there is an element with a compound as both products and reactants, then it is a single replacement. If there are two compounds as both the reactant side and the product side, it is a double replacement.